Good afternoon, fifth grade friends, and welcome back. I hope you all had a really nice weekend. It was a wet day yesterday, but we needed some much needed rain. So I'm really glad that we had a nice weekend, and I hope you did too. So today is our final day together, fifth grade. And I wanted to let you all know that I have truly enjoyed doing this. And a lot of folks have reviewed for today, but I'm going to continue on with fractions. And where we've been multiplying fractions, today we're going to look at dividing fractions, okay? Now you really need to pay close attention because at the end, I'm going to have a question for you. And that question, if you answer it correctly, email it in to mcpsstv.com. That question, if you get it right, you might have a chance to win a Chick-fil-A gift card or a really cool t-shirt. So I hope that you pay close attention, and I hope that you will participate in our fun little contest. So today we're going to continue with fractions, but again, like I said, we're going to be dividing fractions by whole numbers and whole numbers by fractions. Some really some important key terms that we've been looking at: numerator and denominator, the same thing that we've been looking at, equivalent fraction, number line, area models, simplify, and instead of finding the product today with fractions, we're going to be finding the quotient. And we're also going to still be estimating and benchmarking as well. So let's take a look. Let's look at our exit ticket from Thursday. On Thursday, I asked you to multiply the following: half of 3/5 and 3/4 of 6/5. So if you did just standard multiplication, half of 3/5 would be 3/10. Yeah, because we just simply go, whoops, look at that. Straight across. 1 times 3 is 3, and 2 times 5 is 10. 3/10. Now, if you look below, I have 3/4 of 6/5. Now, remember, 6/5 is considered an improper fraction. 5/5 is 1 whole, and so 6/5 is really like saying 1 whole and 1 more piece left over out of the 5. So 6/5 is 1 and 1/5. And so if you're thinking about 3/4 of that, sometimes that's hard. But if you keep it as an improper fraction, then you can just simply multiply straight across with your numerators, multiply straight across with your denominators, and when you do that, you get 18/20. Now remember what I talked about with making things more simple. I want you to think about having a fraction bar or a number line, and think about trying to divide that number line into 20 sections, or that fraction bar into 20 sections. That's kind of hard to do. So is there a more simple way to show this? Yeah, when you look at both of those numbers, automatically I think of those as being even numbers. And so they probably both have the same factors. In this case, they both have a factor of 1, obviously, and a factor of 2. So let's divide the numerator and the denominator by 2, and let's see what happens. Now, as a reminder, before we keep going, when I simplify this, it still needs to look about the same. 20/20 is 1 whole. So if I benchmark this, if I estimate, I see that that's really close to 1 whole. So even when I make this more simple, I still should be really close to 1 whole. 18 divided by 2 is 9, and 20 divided by 2 is 10. Now, that looks much more simple. I could probably draw that a lot more easily than I could the 18/20, and they are equivalent. They're still the same. If I estimate, is 9/10 close still to 1 whole? Yeah. And if you think about a fraction of 6/5, 3/4 of 6/5 is close to 1 whole. So we did it correctly. All right. Hope you did that well on Thursday, and now let's keep moving forward into dividing fractions. Division of fractions with whole numbers and whole numbers by fractions sometimes can get a little confusing. A lot of times there is a little trick that teachers teach with dividing fractions. Today I'm going to mention that trick, and I bet you'll know it if you've been learning dividing fractions in third quarter like most of us did. But I'm going to explain the why behind dividing fractions, and hopefully it won't be as confusing. Sometimes when we do tricks in math, I always say tricks are for dogs, not kids in math. So we need to make sure that if we do a trick in math, we understand the why behind it. Let's take a look at the brain teaser. I want you to try to visualize this. It says Alex makes 2 pounds of bread dough. He splits the dough into 1/4 pound loaves before baking them in the oven. How many loaves does he make? Well, when I see this, I see 2 pounds. Here's pound 1 and pound 2, okay? So there's a fraction model, but I want you to look down here at the bottom of the screen. It also says the number line. It says draw a number line and label it to show the 2 pounds of bread dough. Well, it's labeled for you. Here is pound 1 and here's pound 2. So essentially this number line is the same thing as this fraction bar. Then it says to mark the number line to divide each whole into fourths. If you think about it, the 2 pounds of the bread dough is broken up into fourths. And we're going to figure out how many loaves he makes when he breaks it into fourths. So here's pound 1, and this is 1/4, 2/4, 3/4, 4/4. How many fourths are there? 4 of them. So in that first pound, he has 4 loaves. I can do the same thing here with my fraction model. I can break it up into 4 1/4 loaves. So there's those 4 loaves there. Then the second loaf is also broken up into 4 1/4 sections. So now if he has 4 1/4 pound loaves there and 4 more there, he has a total of 8 loaves. And again, we can break that loaf up as well. So it looks like this, 2 loaves divided by 1/4. So they took those 2 loaves and they broke them in to 4 sections each. The first loaf, 4 came out of it, and then the second loaf, another 4 also came out of it. So when we divide by fractions, sometimes it confuses folks because they automatically think if I'm dividing by a fraction, I'm going to get something smaller. But in this case, when you divide a whole number by fractional pieces, you actually get more. So he took those 2 pounds of dough, and when he divided them into fourth sections, both pounds, he got 8 1/4 loaves. And so our answer is 8 whole loaves. All right, so let's take a look at that again. Now we're going to take 2, and instead of dividing it into 1/4 loaves, we're going to look at dividing by a fifth. Again, when you look at this, it's basically saying I have 2 wholes and I'm going to break them into smaller pieces. So I'm going to have more pieces than what I started with. And that's really hard sometimes for kids to understand when you're dividing by a fraction. On number lines, I have 2 right here. And if I divide each of the 2 into fifths, I'll have my quotient, my answer. So from 0 to 1, I need to create 5 1/5 sections because 5/5 is 1 whole. So if I break this into fifths, 1, 2, 3, 1, 2, 3, 4, 5. There's 5/5. So there's 5 sections there. And if I break this from 1 to 2 into fifths as well, I have another 5 sections. And so 5 1/5 sections and 5 more 1/5 sections makes 10. So 2 divided by 1/5 would be 10. This number line can also look just like a fraction model if you think about it. Here's my model broken into 2. And I can do the same exact thing that I did on my number line. I can divide the 2 sections into 1/5 pieces. And that is how we find the quotient of dividing a whole number by a fraction. Now, standard division, I want you to think about this. How many of you have heard the trick? Keep, change, flip. Sometimes teachers even say, oh, you better do K, C, F. And that's fine, except for the fact that a lot of kids don't understand what that means. Keep, change, flip basically means we're going to keep the 2, we're going to change our sign to times, and we're going to flip the fraction. 1/5 becomes 5/1. Well, what is 2 times 5? Yeah, it's 10. But the problem with that is that kids just learn that trick and they don't know why. So essentially, if you really want to do it the correct way, what you're looking at is 2 divided into the 1/5 sections. You're basically saying that you're going to take these 2, divide them into fifths, and that's why you get 10 sections of 1/5. That's why you get a whole of 10. So if you do the trick KCF or keep, change, flip, that's fine, but you need to know why. And this is the reason why. Okay? All right, let's now put that in with a word problem. And I want you again to visualize this and think about this and how this goes with recipes. Remember last week we baked a pizza or we did different pizza toppings, and today it's about pancakes. A lot of times with fractions, when we're adding fractions, dividing them, multiplying them, we use them in cooking. So it says Gemma made 5 cups of pancake batter. So here are the 5 cups. She uses a scoop that holds 1/3 cup to pour batter onto the skillet to make each large pancake. Use the model to show how many large pancakes she can make. So I want you to think about 1 whole cup of mix. And in that cup of mix, she's able to scoop out 1/3 cup, 1/3 cup, 1/3 cup for pancakes. So if I have 1/3 cup, 1/3 cup there, that's 3 large pancakes that she can make. Well, what about the next cup of pancakes? Now, pancake mix, excuse me, how many pancakes are there now? We have 6 pancakes. So if we have 5 cups, and we can have, each pancake has 1/3 of a cup, I want you to look at the rest of this and tell me how many pancakes is she able to make if I take those 5 cups and I divide them by 1/3. 3, 6, think about the next cup. There'll be 3 more, right? Yeah, so 9 pancakes, 3 more, 12 pancakes, and then 3 more, 15 pancakes. So she can make 15 pancakes because each pour that she has with her 1/3 cup makes a pancake, and she has 5 cups. And remember, 3/3 is 1 whole. And so that is why you would get 15 total, because we are taking that 5 and breaking it into more parts, into 1/3. All right, well, what about dividing a fraction by a whole number? That's hard for kids too. So we're going to still go ahead and we're going to use the same recipe or the same word problem we just had. Suppose Gemma makes 1/3 cup of pancake batter to make 4 mini pancakes. So in the last part of the problem, she had that 1/3 cup to make a large pancake. Now she's going to have that 1/3 cup, and she's going to actually divide that into 4 mini cupcakes. So basically it looks like this. She has that 1/3 cup and she wants to divide that 1/3 cup by 4 mini pancakes. And I want to know how many pancakes she's able to make with 1 cup of batter. Remember, 1 cup was broken into thirds. So now we'll take that 1/3 and instead of making 1 large pancake, we can divide that into the 4 small pancakes. Same with this one and this one. And so when you look at that, you should be able to tell how many mini pancakes are in each cup. Do you know how many mini pancakes are in each cup? Yeah, we're going to have 12 of them, 1/12, because 1/3 divided by the 4 makes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. She has 12 mini pancakes, so 1 out of those 12 would be the 1 pancake. So 1/12. Again, if you use the keep, change, flip trick, then standard division, 1/3 divided by 4. We keep 1/3, we change the sign to multiply, and 4 is like saying 4 over 1, so 1/4. There's the multiplication problem. It becomes 1/12, but that's the y behind it. This is the y right here. Do you think I can break this up into a number line as well? Yeah, I could take this exact same thing and instead of using a fraction model, I could use a number line. I could break it into thirds. So let's do that right now. If I have my number line and I have 3/3, 1/3, 2/3, and 1/2 or 3/3, again, I can break these into 4 sections to make the 12. And so 1 mini pancake is 1/12 of the batter. Okay? Here's another one. Show 1/5 divided by 2. Here's my fraction model. Here's 1/5 there. And I can, look, there's 2/5, 3/5, 4/5, 5/5. Well, if I have 1/5 and I divide it into 2, there they are. And so that section there would become 1/10. You can use the equation like I just showed you as well, and you can even flip it if you had to. You have 1/5 divided by 2. It's basically like saying I took that 1/5 and didn't I break it in half? Yeah, I took that 1/5 and I broke it in half. So when you say 1/2 of 1/5, it's the same thing as saying 1/5 divided by 2. You took that 1/5 and you broke it in half. And if you do that, there it is, 1/10. That's that keep, change, flip you're looking at. So think about it like that. Okay, as a reminder, I got it right with MCPSS. Today, as a reminder, if you answer this question correctly, through your email, you have the opportunity to win a Chick-fil-A gift card or a really cool t-shirt, okay? Now let's look at the question. I want you to really think about it. I want you to visualize this. Again, thinking of what the problem is stating. Dylan makes 3 submarine sandwiches. Okay, so can you visualize those 3 sandwiches? He cuts each sandwich into 6 to share. So think about 1 sandwich broken into 6 pieces, the next sandwich, 6 more, and the next. He stacks all the sandwich pieces on a plate. How many sandwich pieces does Dylan stack on the plate? Now it says, show your work. Well, if you're emailing it in to mcpsstv@mcpss.com, you might not be able to show your work. But I want to ask you to do this. I want you to tell us your answer, right? Tell us the quotient. And then where it says show your work, I would love for your answer to have an explanation. You know, one of the main things we want to do in math is not just be able to answer a question, but explain how we got the answer. So where you might not be able to draw a number line, or you might not be able to draw a fraction bar, I want you to tell us how you solved this problem. Did you picture the sandwiches? Did you draw it out? Did you cut up a fraction model? Did you do your standard way of dividing? How did you solve this problem? Okay? All right, look here. It says one smart cookie. It makes me so sad to know that today is our last day together, but I want you to know that you are so smart, that you are so capable, and watching these lessons and working online or in the packet with your teacher has made you really, really smart and ready for 6th grade. Don't forget to email mcpsstv@mcpss.com to have the chance to win a prize. And hey, look guys, now it's time to celebrate. You've made it through 4th quarter. You've made it through a very interesting and different 4th quarter as well, if you think about it. You've never gone through anything like this before, so it's time to give yourself a big pat on the back and tell yourself congratulations for all your hard work. And I thank you for tuning in and listening and learning along with me. I'll be anxious to see who wins the Chick-fil-A gift card or the really cool t-shirt. Okay, have a great summer, boys and girls.